Hello everyone. So today we will start with fuel and combustion part 2. We are talking about fossil fuels with a particular focus on coal. So last week we talked about regular fuel bed furnaces. So for example, there's hot air coming in from the bottom and there is coal dumped on the top. So hot air passes through this coal and gets burnt and transmits hot air. Sorry, not like, sorry. Regular air just comes in, burns with the coal and goes to the boilers as hot air or wherever we want this flue gases to go. So that is a simple process that we just dump in coal from here, for example, in a just a regular conveyor belt or something, or we try and just spread this coal everywhere, or with a vibrating bed, or with like underfeeding coal. So these all involved a bed of coal. These all involved a bed of coal where uh, the air comes and burns this coal and goes up to the heat consuming device. So now we will talk about pulverized coal furnaces. Pulverized coal furnaces are different in the way that they use crushed coal or powdered coal, which is also called pulverized coal, again, as explained with the name. So, as you can see here, what we do is we supply coal to this pulverizer and we supply air, hot air to this, and we sort of use this air to actually transport this coal up to burners. Let me just make it cleaner so you can actually understand this. So coal comes in here, air comes in from here. Air is like moderately hot, it's not completely hot, but it's just hot enough to actually absorb all of the moisture. So you just take all of the moisture away, and dry air and coal goes to the burners, which is supplied with secondary air. Secondary air helps just burn this coal completely, which is actually 70% of the total air. So primary air's objective is just to take this coal, a very high concentration of coal, into the burner, and we use the secondary air to actually distribute the heat as well as ensure the complete combustion of this coal. So you can see that air is being pumped in, it is heated by the flue gas, then it is secondary, then it is heated again at the primary air heater and sent directly to secondary air. So you can see it here. The the best advantage is that since the coal is very small in size, the combustion is actually pretty smooth and overall complete. So a large surface area ensures that combustion of the coal is very significant. But some of the problems of pulverized core are that it actually releases a lot of coal dust. So coal dust is very toxic and very harmful for us. So it starts a lot of lung problems in the people who actually work at these coal plants. So what we do is we actually go somewhere in the middle of using complete uh, large coal chunks and like completely pulverized coal. So what we do is we actually use crushers to make 30 like, which is about an inch or a smaller size coal piece. So that is still a solid object, actually a full piece of coal, but it is not large enough to actually require minutes or even hours of burning. So what we do is we actually dump coal here. We have a ring crusher which is uh, rotating here, and these can rotate here as well. So what happens is coal gets trapped here, for example, and some of the big chunks of coal which are trapped here come here and then break apart, and then they are left here. And now what happens is if they are small enough, so they will move there, they will actually drop from here. But if they are large enough, they will stay here and they will get crushed with this subsequent uh, layer of coal. So similarly, hammer crushers, they have different hammers. Um, they can have a certain like motorized movement like this, or they can simply just move like this and then crush coal how they are going. And these are adjustable. So for example, if you want a large coal size, you can keep this a bit far away, and if you want a smaller size of coal, you can put it forward. So um, this makes a very sort of homogeneous size of coal, and it is dropped here. You have the third type, which is called a Bradford breaker. You can see it in this direction that coal is actually taken in sort of in different sized like these crates, and when this moves upward, this falls down because of gravity, and this breaks the coal into smaller chunks. So because of this velocity and everything, and you can keep this size at a certain limit. So this is sort of a mesh. If the coal gets smaller than like 30 mm, or for example in one of the scenarios, if the coal gets size gets smaller than 30 mm, this coal gets dropped from this crusher. Let me just clean it up so you can see better. So this coal can actually drop from this mesh into this assembly, and the bigger chunks get transported again upwards. And it doesn't matter how long a coal chunk is in there, because it is continuously being fed with new coal, and you will get a constant supply of small chunks of coal. So you can have some coal particles which might not break in the first rotation, or even second rotation or third rotation, but as long as you have fresh coal coming in, there will be chunks which will get smaller, and they will drop into the uh, supply. So uh, when you have crushers and pulverizers, so pulverizers are you can see that pulver. Okay, so in a pulverized coal furnace, we have two options. We have one option of actually taking this coal at and dumping it and at like a horizontal direction, so that the hot air the hot air actually moves upward, and eventually when this ash tries to fall down, it loses its temperature and lands at the bottom. There is an Archimedes screw here. Um, so which actually I'm not sure if this is the right spelling, but this takes this ash to some sort of a dump, so we can actually just take this ash and just dump it somewhere. So this is called a dry bottom because this ash has time to actually solidify, and this is sort of a solid ash which is being dumped. On the other hand, we have which is called a wet bottom furnace. What wet bottom furnace does is actually it uh, directly um, allows the ash to be captured while it is in the molten state, and it just allows this for this hot air fuel mixture to actually rise up in the boiler. So this is an important design because it is not only showing you the burner part of it, it is also showing you the boiler part of the equation. So you can see that this is a fire shell kind of an arrangement. So we have these water tubes which are actually in the boiler. So this boiler takes in input from the economizer. As you can see that this is colder air fuel mixture, colder exhaust gas, flue gas. So we run it in the economizer. Economizer goes in the boiler, and since from the boiler we go to superheater. So since the first superheater can be actually at a lower temperature, right? Because the gas has just boiled, we can use a colder air fuel mixture to heat it up initially. So when we heat it up here, then we take this into the primary superheater, which is at a very high temperature. We take most of the energy out here and then use it in the primary turbine. And then if we have a reheater, then there is installed here, and that goes to the secondary turbine. So you can see a lot of things happening here. Um, there is also uh, an air heater. You can use this still hot air fuel mixture, this still hot flue gas, to actually heat the incoming air, which is going to burn the coal. Just get rid of these. So now we go to the third type, which is called a cyclone furnace. So right now we have talked about fuel bed. We have talked about pulverized coal furnaces. So the disadvantage of this is it is too slow, and the disadvantage of this is it is too toxic, and it involves a lot of complicated machinery, complex. So we go to cyclone furnace, which is sort of the middle ground of both of these. In cyclone furnaces, what we do is we actually crush the coal to a reasonable amount, and we sort of make a cyclone of air and fuel. So this coal is burnt thoroughly, and we only get 15. This is actually a pretty large number though. 15 to 40% ash leaves with the flue gas. So in pulverized coal, you will have a lot more ash because the ash is actually very small. It is the size of a small particle, so that will actually go on completely with the flue gases, and that will result in corrosion and erosion. But in cyclone furnaces, since the size of this coal is actually reasonable, we have 30 to 60 mm. So the ash actually is larger as well. So we can actually get a good result out of it. Um, you will see the one disadvantage here is since we are using a lot of air, the primary air is about 20% of the secondary air. So we are using so much air in this that we are producing a lot of nitrous oxide as well, NOx. So, but if you remember the Askri cement visit, the furnaces they had were actually cyclone furnaces. So it is used a lot in industry, especially because it is also usable with poorer grades of coal. This actually this vaporizes moisture as it is burning in the furnace. As you can see here, cyclone furnace, it involves coal being pushed with primary air into a sort of cyclone. So this coal, when it is moved in, it will sort of start rotating like this. So when it is rotating like this, and we are supplying with secondary and tertiary air, this will cause actually a large cyclone, which will result in the coal being supplied air from all sides, and this will result in the coal being completely burnt. And since the air is actually moving in this direction, this will take some of the ash with it, and the hot flue gases will actually move upwards towards the boilers. So you can have some sort of a trap door here that will cause most of the air to actually go upwards, but it will make the ash drop somewhere here, and the ash can be collected in this direction. Let me just clear it up so you can see it better. So we have a large cyclone here, ash gets deposited here, and hot flue gases deposited here. Okay, so now we move on to the next topic, last furnace kind, which is called the fluidized bed furnace. So last topic we saw, last sort of device we saw was the cyclone furnace, and cyclone furnace was successful because it actually caused air to interact with all sides of the coal. But coal has a tendency of sticking to the sides, and so the sides of the furnace, so the efficiency is slightly hampered. What we can do to improve that efficiency is actually suspend this coal in a sort of bed of air, so that we ensure that this sort of circumstance happens, that coal is being burned by air in all of the directions. So you can see that we need, obviously, since we have a coal which is a solid particle, we need to supply a lot of air to keep it suspended. Obviously, this coal will have its weight, so that will try and act toward, that will try and move towards the ground. So we need to supply force, the drag force from air, which is equal to the amount of weight of this coal. So that is dependent on the coefficient of drag, that is dependent on the area of coal and the density of um, I'm not the density of air as well. So all of this combined gives us the pressure, which is sort of pressure and velocity, which will allow us to maintain the optimum height of coal particles inside this bed. Obviously, the larger particles will tend to move towards the bottom, since they will require a much larger flow of air, but the smaller particles can be suspended at a greater height. So that will ensure that there is a sort of reasonable distribution of coal in the air. Again, since want we we are restricted by the weight of this coal, so this will use a small crushed coal. So that is 6 to 20 mm of coal size. But in the cyclone furnaces, we can use up to 60 mm. So that is somewhat of a restriction for us. Um, Again, the temperature gradient here will be smaller. That we can only get 750 to 950 degrees Celsius of output air temperature. It might be sufficient for some applications. It might not be sufficient for some other applications. Um, some of the advantages are that since this process is actually at a lower temperature, we are producing a lot less NOx. That is one argument, that we are using a lot of air, extra air, but since the temperature is so low, that NOx does not form. Sulfur is actually removed by adding limestone. So limestone reacts with sulfur oxide to produce calcium sulfate and carbon dioxide. Um, you don't need pulverizers, you just need a very fine crushing equipment. So you have atmospheric uh, fluidized bed furnaces, which obviously will mean that the velocity of air particles has to be very large, so that they can sort of create a force which is pushing the coal particles, or pressurized. If we maintain a pressure of 10 to 15 atmosphere inside this furnace, then we might need less velocity um, of this sort of fluidized bed, so that we can actually burn this coal. So again, it is important to understand that once we get the coal burning initially, then that sort of has a chain reaction that once we get this coal to be burning, for example, we can supply it with hot air initially, or we can add an accelerant or anything. When we start the combustion process, or maybe natural gas combustion here, then this will produce enough heat to sort of start a chain reaction, and this will sort of make sure that all of the coal burns when we start the combustion process. So this will actually mean that there is a large flame and you're just dumping coal in, which is being suspended in the air as it is burned and adds heat to the hot air to the boiler or anything which you are using. But again, this temperature is restricted to about 750 to 950 degrees Celsius because again the volume of air is very large. So this is a very efficient kind of a furnace, but again it has its restrictions. So now we have talked about four different kind of processes, four different kind of furnaces, and let me again reiterate some of the advantages and disadvantages. First, we have the fuel bed furnace. So fuel bed furnace actually is simple and does not require any crushing. But the disadvantage is it is a very slow and inefficient. Then we have the pulverized coal, which addresses a lot of its problems, but again, um, so it is fast, it is efficient, but it is complicated and it requires pulverizing coal. Okay, so then we have cyclone furnace, which is sort of middle ground of both technologies. Sort of, it is slower than pulverized, but it is faster than fluid bed, and it is simpler than pulverized, but more complicated than fuel bed. And again, it is still very efficient. Then lastly, we have the fluidized bed. So that is basically finely crushed. So that is complicated, but again, it is it is efficient, more efficient, but also non-toxic. And we can see these some of the other advantages here as well. So one of the very big disadvantage of pulverized is toxic environment. Yes. So this is the sort of summary of our combustion equipment and combustion mechanisms. I will share any sort of material I can find on this fluidized bed furnace if I can find any diagram of it. But I would again recommend you go into the book and let's like see the examples written there, which will help you understand. Okay, goodbye.